Hello and good afternoon, CSI258, Section 847 students for the second 8-week term of the spring 2015 semester at Anne Arundel Community College. This evening's Packet Tracer tutorial is going to be on Packet Tracer Activity 5.2.3.6, where we're going to be implementing static and dynamic NAT. And as we can see here from the diagram, we've taken kind of an inductive approach here where we started out small with static NAT. We did Packet Tracer Activity 5.2.2.5, introduced dynamic NAT, and now you can see where we've got the router here. I'm going to kind of draw our little boundary that we've become used to, that everything over on this side, this is going to be the inside global area, right, where the inside global addresses will be found. This is our internet out here. And then we also have what's going to be, and I'll write it down here, is our inside local area, where we're going to have all of our RFC 1918 IP addresses, right? So our 192.168s for each of our segments here. And you can also see we've got a local.pka server here. So, and our guess is that this guy's probably going to be our static NAT. And then again, the use case, right, when we talk about when to use the different types of NAT, if we want to initiate a connection from the internet, so from outside of our internal network, we need to make sure that our inside local RFC 1918 IP, which is this 192 right here, we need to make sure that we statically map that to one of the inside globals that we're going to be using. That way it doesn't change. Hence the name statically mapped. Now, that's the use case for a box, a server, right, web server, whatever it's doing, that we want to make sure we have connectivity. We can initiate connectivity from the internet, right? So the use case for static, that's one of the use cases. And then the IP doesn't change. Now, when we have PCs, and as we saw in Packet Tracer 5.2.2.6, the previous Packet Tracer, these are workstations where you probably have employees who are just trying to access the internet to get to research, to get to whatever information it is they're trying to find. And you're not going to need to go from the internet, so initiate a connection from the internet. You're not going to do that and try to get to one of these PCs where you've got your employees sitting. So the use case for dynamic NAT in a scenario like this is perfect, and especially when we've got a small number of PCs. As you can see, we only have two PCs here, PC1 and PC3. So dynamic NAT would fit the bill. So let's take a look at what they're asking us to do. Configure dynamic NAT with PAT, right? Configure static NAT, and then verify our NAT implementation. So we're going to be doing NAT Overload, right, which is a.k.a. PAT, Port Address Translation. So let's take a look here at step one. So step one is asking us, do Control C there. Step one is asking us to, on router 2, so we've got router 2 up right here. It says configure a standard ACL named R2NAT that uses 3 statements to permit, in order, the following private addresses. So let's go ahead and we're going to go from user exec into privilege exec with the enable command, and then into global config with the configure terminal command. And we're simply going to say it's a standard access list, so access list 1, and the first subnet we want to permit is going to be 192.168.10.0, and then our wildcard mask is sorry about that, yeah, 0.0.0.255, because we have a /24. These are all going to be /24s. So that's going to be our first permit, and then the second permit, it's going to be an easy change here, the 20, and then in order the 30. So if I were to say do show access list, there's my standard access list, and it has each of the subnets in order as the activity has requested. All right, so now we're going to move on to step 2. So we've created the ACL, which we're going to reference and associate with our pool so that the router 2, knows which addresses coming from which subnets are allowed to establish an inside local to an inside global mapping inside the NAT translation table. So configure a pool of addresses for NAT. So configure R2 with a NAT pool named R2 pool. So we know that that's going to be IP NAT pool and then the name of our pool. So they're requesting that we do R2 pool that uses the first address in the 209.165.202.128 address space. Now, again, here's where some of the subtleties and some of the confusion comes into play with NAT for new learners. So the previous activity, remember how the previous activity phrased this? It said using all 4 addresses in the /30 space. However, we know that it's not actually making all 4 of those addresses in the /30 space available for NAT, because the /30 implies that we have our broadcast address. If I'm not mistaken, the last exercise it was .196. .197 was the first usable. .198 was our second usable. .199 is our broadcast, right? And remember that this was the network or the subnet ID. Okay, so the only 2 addresses that we could use were 197 and 198, and we saw that because after the first 2 clients connected through and they established an inside local to an inside global mapping, these addresses right here got used. The 3rd client who tried to connect through was denied. And so again, it can be a little confusing reading that, thinking, well, why am I not using the 196 and the 199? Because the statement said use all 4. I put the right subnet in there, right? The right starting IP and the right ending IP with a /30 subnet mask, but it's only letting me use these 2. And that's because in a /30, there are only 2 assignable usable host IPs. So now let's take a look at the wording here. It says that uses the first address in the 209.165.202.128 address space. Well, if it's 128, right, is our network ID, kind of going off the page here, the network ID, we know that in a /30, .129 and .130, these are going to be my usable IPs. .131 is going to be my broadcast address, right? So now this is interesting. The second address is used for static NAT later in part 2. So how would you say only use that IP address right there? And if you're thinking I'd make the starting IP and the ending IP the exact same address, you're correct. So let me go ahead and come back over here. We've got our pool. If I do a question mark, it says the starting IP address. Well, we know that it's going to be 209.165.202.129. Now, the reason we put the 129 in here and not, and this is going to be wrong, right? So if I were to do this, .165.202.131, whoops, 131. Now, and we'll go ahead and add the net mask in here as well, because it's going to stay a /30. So this statement that I have up here right now, this is a valid pool statement. Because remember, when we created the pool using all 4 of the addresses last time, what did it look like? It looked just like this. We put down the subnet ID as the first IP, say net ID, and then the second IP was the broadcast address, right? Remember, we did 196 to 199, and that worked. However, when I do that, it implies that those 2 addresses and both of those addresses are now available to be used for my dynamic NAT, right? So if I were to leave this like this, this will work, but it doesn't achieve the desired result. Because what's the desired result going to be? .129 and .130 will both now be made available for use in dynamic NAT. And that's not what we're being asked here. Remember, it says the first address in that address space. It's not saying all 4 addresses. So we know that in a /30 with a 128 network ID, the first usable is 129. So let's go ahead and let me back up here, hoping that we can get all of this out of the way. And we cannot. So let me go ahead and clear the screen real quick and let me redraw real fast here our inside global, and we'll say this is our inside local space. All right, so let's come back here now and let's correct this statement. And I hope I did not just run that. Do show run. Let's make sure I didn't run that. We'll have to pull it out. It doesn't appear that I did. So yeah, did not run that command. So let's go ahead and do it again. So IP-NAT pool, R2 pool, excuse me. What's our starting IP? So 209.165.202.129 is my starting IP, and 209.165.202.129 is my ending IP. And so really all I'm saying here is, by giving the same starting IP and the same ending IP, I'm basically saying that my NAT pool, that's it. I'm using this single address in my NAT pool, and that is it, right? And that's how you declare that. All right, so let me pull these guys out of here. Okay. And then finally, we're going to go ahead and put our net mask statement in there, and we know that it's a /30. Now, remember what iOS is doing here, because I've already declared the specific IP and only that IP. When I hit enter, iOS looks at that command, breaks the command line down into tokens, and says, okay, if he's indicating that this is going to be a /30, which we did with our net mask right here, right? So iOS says, all right, he says he's going to use a /30. However, he's only got this single IP address as the starting and ending IP. And iOS does the math to figure out that 129 cannot be a network ID. Because remember, the network ID is always an even number. So iOS does the math and figures out, if I'm in the 209.165.202 address space, we'll say 202.0/24, right? But I'm using a /30, it's going to figure out, okay, well, if he's doing /30s, it's going to be from .0 to .3. So my block size is 4, right? So let me clear these out here. Let's clear some of this mess out of here. So if my block size is 4, it's going to go from 209.165.202.0 to .4, .8, .12, and I think you get the idea. And ultimately, it gets to .124, and then it goes to .128. The next jump up is 132. So iOS does the math and figures out, hey, he's talking about 129. It would be in this subnet. It has to be in that subnet, right? Mathematically, it can't be in another subnet when we're defining /30s. So iOS now knows that, okay, there's another IP in here, but he's not using it. He's using this single IP address that has to fall in that subnet right there. And again, this is different from the exercise 5226, where it specifically stated use all 4 IPs in our declaration, and that's where we went ahead and said the first one's going to be the network ID, the last one's going to be the broadcast, and at that point we're committing ourselves to the 2 IPs in the middle that they are going to be used for dynamic NAT. All right, so hopefully that makes sense, and that's a significant difference. The way we define the statement here, saying just this single IP, even though there's a second IP, we know that the second IP, here it is right here, second IP address is used for static NAT later in part 2. Okay, so let me go ahead and try to back this out. I'm not sure the history is going to allow it. So we'll clear the screen here and quickly draw in inside global, inside local space. Okay. So we've got our pool statement in there. And what is it asking for now? It says associate the named ACL with the NAT pool. So the first thing we do is we define the ACL, which defines the inside local addresses that are allowed to create a mapping to an inside global address. Second step is we create that pool of inside global addresses, which we just did right here. However, this isn't really much of a pool, right? So remember, dynamic NAT can be one to one, it could be one to many or many to many, right? Because if we only have a single host and we define a pool that's a size of one, theoretically you could have one to one. However, that might not be the best utilization of a dynamic NAT configuration. But there are cases where you may want to do that because, again, the use case for static NAT is when you do the static NAT, you are now making it possible to initiate your connection from the internet somewhere and to try to get into that host because it has a static mapping on the router to an inside global address. All right, so we're going to make that association right now. So I'm going to say IPNAT inside, and it's going to be source, and remember it's list, because what's the list that we're going to use here? We're going to use this standard access list. We didn't use a named access list, right? We used a standard access list, so it's just simply number 1, and we want to associate it with pool R2 pool, and we'll hit enter. So now we've made that association between the ACL and the pool. So configure the NAT interfaces. So on router 2, if I do a do show IP interface brief, we can quickly see that serial 010 is going to be the IP NAT outside address because this has the inside global range, right? So I'm going to go ahead now and say IP, oh wait, let's get into the interface here. Interface serial 0/1/0, and we're going to go ahead and say IP NAT outside, right? Because that is the outside NAT interface. So the next thing that we're going to do is we're going to go to the next 3 interfaces. We've got 3 we need to get onto here. Fast Ethernet 00, and then serial 000 and 001. So Internet Fast Ethernet 00, and we're going to say IP NAT inside. We're going to go into interface serial 000 and say IP NAT inside, and interface serial 001 IP NAT inside. So we've now gone ahead and declared, and let's do a do show run. So we've got the IP NAT inside on the fast Ethernet interface for the 192.168.20 subnet, the serial 000 interface for our 10.1. For the 192.168. That's going to be on the 10 subnet, and then the serial 001 is going to go down to the 192.168.30 subnet. So we have all of the entries in there. And let's take a look at our IP NAT outside, or did we I actually went by that by mistake? And there it is right there, IP NAT outside on the serial 010, facing the service provider, right, or the internet, because that's where our inside global addresses will be. Okay, so we've got that configured. The next thing we need to configure is our static NAT. Now it says refer to the topology, and so if you look right up here, you can see, we can clearly see what we're going to be using for our static NAT, and lo and behold, there is the address that would be the second usable IP in that /30 that we were looking at earlier. So let's go ahead and knock out our static NAT. And again, the static NAT is very, very straightforward. So it's IP NAT inside source. And if I do a question mark here, you can see this is where you typically make your decision. Am I going to be doing a pool of addresses, or am I going to be associating this with an access list, or is this going to be a static entry? And in this case, it's going to be a static entry. So now I'm going to define my inside local address, 192.168.20.254, and I also want to define or declare the mapping that I want to create, the static mapping I wish to create. And so it's the inside local to the inside global, and the inside global is going to be that second IP out of that /30 range, so 209.165.202.130 that we wanted to use. And that's it. So there is our static declaration for static NAT. All right, so we've got everything set up and ready to go, and I'm wondering, it's saying NAT with PAT, and so you know what? I completely looked over that thinking just dynamic NAT, so I will bet you that it is looking for, and let me go ahead and do a do show run here. We're going to have to adjust, yeah, the IP NAT pool command. Where are we at here? Inside source static, inside source list, and we're going to have to adjust the command that we typically use for dynamic NAT without the PAT configuration, the overload command. And so that is typically where you associate the access list with the, whoops, I'm one away there, with the pool. So let me copy this. Sorry about that. I just realized I read right. I was so wrapped up around the dynamic NAT setup that I overlooked the PAT configuration. So when we get to the association part, where we associate the ACL with the pool, if I leave it here, it's dynamic NAT and it's dynamic NAT only, right? And in the scenario that we have here, we're only using a single address. So it doesn't make much sense to use just one address if we're not going to do NAT overload, which is a.k.a. PAT, port address translation. And so I want to make sure that we have the overload keyword on there, because once we go above one host, we wouldn't have anybody else capable of connecting to the internet, because that dynamic mapping is going to get used right up. So let's do a do show run and make sure that we don't have any extraneous entries in here. All right, so that looks good. So it wants us to verify we created the static map translation. Let's check results here. It looks like we're 2 configure items away. NAT source setting and the ACL R2 NAT. Did it want me to name that? I did not see that, if that was what it was looking for. And NAT source would be wrong because, so does it say name the, oh, it does, named R2 NAT. So, okay, we can handle that. So I'm going to say no. And where is that? There we go. Where's the access list at? No access list. Did I not get to it? Yeah, so we're going to do a named ACL here. So let's just say, whoops, no access list 1. So we'll get rid of that access list. So we're going to come back, we're going to say IP access list, whoops. And now we're going to say it's going to be standard, but because we preceded the command with IP, we can now make it a named ACL. And I apologize, I read right by that. So we're going to call this R2 NAT, and let me make sure I've got that correct. All right, and it's going to be, whoops, sorry about that. We're going to put our permits in here. So permit 192.168.10.0, and then 20.0, and then 30.0. And now the ACL is correct. However, what is still referencing that old ACL, right? You can see it right here, our overload statement. So let me copy that, and we're going to say no. Let me exit out one level. So no. And we're going to rerun that command, and we're going to reference R2 NAT. And again, you could do named, or you could do simply just numbered. So now we've got our NAT statement that corresponds to the access list. So now let's get into our verification. So one of the first things I'm going to do here, I'm going to save my config off, right? So one of the first things that we want to do is, it says from the web browser of PC1, and actually before we do that, let's do a show IP NAT translations. And so this is a very key point here, and actually didn't want to squeeze that over. Let's bring that guy back, and let's take this one here and drag it over. So this is a very key point. So we already have a translation, but we haven't attempted a connection yet through router 2. So why is this translation here? Well, the translation is here because that is a static translation, right? Or a static NAT. Keep in mind that static NATs will always remain in the translation table. They will not time out. And this was interesting when we did the dynamic NAT prior to this. I think I had mentioned it, but just to be clear, by default, when we do dynamic NAT, the timeout for dynamic NAT, so we'll put dynamic NAT timeout, is 24 hours, right? Now, the command that you can use to manipulate that, if you don't like 24 hours, is IP NAT translation timeout, and then a value in seconds, right? And now this is a little outside the scope of the CCNA. However, this was a great question that was asked on Saturday, which is, if the default is 24 hours, there's got to be a way to adjust that. If I don't want, if we're going to run out of inside global addresses, I'd like it to time out quicker than that. And you can certainly do that. And again, here's the command to do that. So let's drop back over here. But we have our static entry in here. And remember, that static entry is going to remain in there permanently until we would have to remove the static entry, right, for it to be pulled from this translation table. Now the dynamic entries, which is what we're going to see here shortly, our dynamic entries are going to get entered into the table, but they will eventually time out. So we're supposed to be doing the web browser of PC1. So let's pull that up. We're going to go to Cisco.pka, I believe is what it's asking. And I'll click go, and there we go. Cisco.pka, welcome to the web page. Now, we quickly go to R2 here and type in show IP NAT translations, and I actually hit the go, I hit enter and then hit the go button a couple times, which is why you can now see in the translation table what? We've got the TCP as our protocol, because again, we're using HTTP, and that is a transmission control protocol, TCP protocol. We've got our inside global address. So there's that inside global .129 that we're using. And then you can see we have our random port that was selected. And again, it doesn't pick the first 1024 because those are reserved. So here it looks like it's starting at 1025. And then it's a little jumbled together. Next, we've got our IP address, our inside local IP address that maps to this inside global. And then it shows us the outside local to which we are going. So you can clearly see here that the IP address of that Cisco.pka web server is 209.165.201.30. And again, this is your source port, and this is your destination port, 80 for HTTP. All right, so let's do the show IP NAT translations again. And it looks like it, because like I said, I clicked it a number of times. Let's take a look at show IP NAT statistics, right? So what does it show here? How many translations do we have going on? There are 5 that have taken place, right? And remember, because we did port address translation, right? We did NAT overload, and which is basically PAT. We are able to use that single .129 address, and now we've got 60,000+ sessions. Theoretically, performance is obviously going to be impacted, but we have a theoretical large number of sessions that we could create. We've got 5 here, right? Excuse me. Here's our single static, and it shows our outside interface. It shows the inside interfaces. It shows our hits and our misses. We have no expired translations, and here's the mapping. The inside source that shows us the access list, right? The name of the pool and the net mask of the pool. the starting and ending IP address. It's a generic one address allocated, 100%, no misses, right? So we're using that address. It's 100% utilized, right? And actually, let me make sure I clarify that. So what that means is we've allocated one address, we're using one address, therefore it's at 100. It's 100% where you've used all of the addresses. However, since we're doing PAT, it's using the ports. All right, so let's do the next step here, which says from the web browser of PC4, which is outside the network, let's try to hit that inside local address, or I'm sorry, the inside global address for our local.pka, right? So I'll hit enter, and then I'm going to hit go a couple times there, right? So it worked. Now let's go back to R2, and let's see what the translation table looks like now. We've got our static entry here, right? Statically mapped. Here are the new inbound connections, and you can easily tell, because if I'm looking at the inside global, inside local, this is the destination port, port 80. So we've got an HTTP request coming through router 2 from these outside local / outside global addresses. And it's the same address, right? It's just different port numbers. So you can see it's 209.165.201.14. So without even looking at PC4, right, that we know the IP address because we can see it in the translation table. And this is a translation coming from being initiated out on the internet, coming through the router into our inside local address. However, it's initiated using the inside global address because that's the publicly routable address on the internet. So now let's go ahead and take a step back here. Let's see, we defined a single dynamic, NAT overload or PAT pool address. So that means that PC3, when it goes to connect, since it's using a port, should be able to hit Cisco.pka. And I'll hit go a couple times here to generate some output. And it does, and it works. So let's see, how is it that the router, show IP NAT translations, how is it that the router is handling that? And so here it is. And actually, no, that is not it. Where are we at here? The inside global, where's my inside local? PC3 would be 192.168.30. There we go. It jumbled it in here on me. And I was just jumping to the bottom. And you can see there's actually one up here. But we're going to take a look at this group. And so here you can see, what did it do? It continues to increment the ports, right? So we started at 1025, 1026, 1027, 28, 29, 30. And this is how the router differentiates the connections that are coming through. It looks at the combination of the IP address and the port number to differentiate the connections. And this is port address translation. And you can see our destination is still going out to port 80. All right, so let's go ahead and do a show IP NAT statistics and see if we see anything different here. All right, now we have 13 translations taking place, right? 1 static, 12 dynamic. Same interfaces, number of hits we've got here, and then it comes down and shows us the pool statistics. And again, we're using that only address, the only address we've defined is being used, so we're at 100%. All right, so speaking of 100%, we've completed this activity. We've got 8 out of 8 on here, and hopefully this gives you a much better idea again, as to the configuration of not only static NAT, but it's interesting, they say dynamic NAT with PAT. The text refers to that as NAT overload, right? So NAT overload, which is PAT. And so, but they're talking about configuring dynamic NAT with PAT. So make sure that you've got a clear understanding that really dynamic NAT with PAT is NAT overload, right? And it's also called PAT. However, dynamic NAT, if it's not using that overload keyword, is only dynamic NAT, right? Okay, So this wraps up Packet Tracer Activity 5.2.3.6. If I'm not mistaken, I think we have the Skills Integration Challenge next, which is going to be a great opportunity to take all of the NAT knowledge we've acquired so far in the 158 course as well as the 258 course and to apply that. All right, thanks for watching, and I'll see you on Saturday.